Okay, let's dive into this. We're on our computers every single day, but there's this whole secret conversation happening right under our noses that makes everything work. Today, we're going to pull back that curtain on the hidden translator that makes it all possible, the shell.
No, really. Think about it for a second. You type ls and hit enter, or you double-click a folder and bam, things just happen. But it's not magic, right? It's this incredibly precise dance going on behind the scenes. So, what's that secret ingredient turning your click into the computer's action?
And that is where the shell comes in. It's the ultimate middleman. See, you don't talk directly to the brain of your operating system. That's the kernel. The kernel's the super busy core program that juggles all your hardware and resources. Instead, you talk to the shell, and the shell does all the talking to the kernel for you. And that translator idea? It's pretty much perfect. You speak in human-friendly commands. The kernel, on the other hand, only gets a very specific, very technical language made of something called system calls. The shell is that genius translator that takes your request and turns it into a system call the kernel can actually do something with.
Okay, so enough with the analogies, right? To really get it, let's follow the journey of one simple command. We're going to trace its life from the second you type it to the moment the result pops up on your screen.
And this is where it gets really cool. So you type ls to list your files. First, the shell reads your command. Then it does this really clever two-step move we call the fork and exec dance. It forks, which basically means it makes an exact clone of itself, a little child process. Then that child uses exec to completely morph into the ls program you wanted to run. The kernel runs it, and boom, the output gets sent right back to your screen.
Okay, but hold on. That's the million-dollar question, isn't it? If the shell's job is to run stuff, why bother with this whole cloning business? Why not just run the command? It feels like an extra step.
Well, here's why it's so brilliant. Your main shell, the one you're typing in, has to keep running. If it just turned itself into the ls command, your shell would disappear the moment the command was done. So it protects itself by forking. It makes a disposable clone, the child, whose only purpose in life is to become the new program. The parent shell just chills, waits for the kid to finish its job, and then you get your prompt back, ready for the next command.
All right, now that we've got the command line down, let's zoom out a bit, because the whole idea of a shell is way bigger than just that little blinking cursor. In fact, you've been using a totally different kind of shell this whole time, probably without even realizing it.
And here it is. This is the big reveal. Your Windows desktop, your Max Finder, the interface on Linux, those are all shells too. They're graphical shells. Instead of typing text, you're clicking icons and dragging windows. But guess what? The job is exactly the same, translating your actions into instructions the kernel can understand. So let's put them side by side. You've got the command line, the CLI, which takes your typed commands. Then you've got the graphical user interface, the GUI, which takes your clicks and drags. The real difference is what's hidden. The CLI shows you all the complexity and gives you total, fine-grained control. The GUI tucks all that complexity away behind friendly pictures. But at the end of the day, they're both doing the exact same thing. Whether you type open my file or you double-click the my file icon, the same thing happens underneath. Your shell, graphical or not, sends these same requests to the kernel. That mouse click, it's just a command in a pretty disguise. So that leads to a pretty good question. If graphical shells are so simple and easy, why do programmers and system admins still live in the command line? What does it have that a GUI doesn't? It all comes down to one word: transparency. The command line doesn't hide anything from you. When you're in the CLI, you're peeking under the hood and seeing the operating system for what it really is. You see the raw file system, you directly control permissions, you see how processes are related. And that's not just for showing off. That transparency gives you the power to automate things and solve problems in a way you just can't with a GUI. So let's bring it all home. From the simplest typed command to a fancy drag and drop, it's the shell doing all the heavy lifting. It's the unsung hero of your computer, constantly translating between you and the deep inner workings of the operating system. And that's really the bottom line. If you want to truly understand how a computer works, you have to understand the shell. It's not just another program, it's the very language you use to talk to the heart of your machine.